this is question 4. The idea that we were talking about yesterday is that when we deal with mid-segments, which the notation here is telling you that this blue segment is a mid-segment, right? Because those markings tell us that E is a midpoint. These markings over here tell us F's a midpoint. We connect those, we get a mid-segment. What was the relationship between the mid-segment and the yellow bases that we talked about yesterday? Cameron?
You add those up, divide by 2, you get your mid-segment.
Okay, so the mid-segment, which is 7x, is equal to the sum of your bases. So can I just go ahead and write that as x plus 78 when I add these yellow things together?
Yep.
Okay, so x plus 78. And you said divide by 2, right? Okay, that is. I think that might even be an approach that some of us want to use. That's a great approach, because what does this, if I write it this way, what does that tell me I need to multiply both sides by? Careful. 2. When you have fractions, you want to multiply by the LCD, the least common denominator, right? And of everything that's in here, my least common denominator is 2. Okay? So I'll multiply this side by 2, and they're going to cancel out. Multiply by this side by 2, and I get 14x, right? Okay, so that is one way, and I'll go back through and finish that math here in a moment. But some of you might have written it this way, because this is the way it was introduced in the theorem yesterday, that the mid-segment is equal to 1/2 the sum of the bases. Oh, I don't know what I'm doing there. X plus 78, right? Okay. What I want you to understand is these two things say the exact same thing. Okay? For this reason. X plus 78 is just a number when I know what x is, right? Let's say x is 0. This would just be 78, right? Can I write 78 as 78 over 1? So why can't I write x plus 78 as x plus 78 over 1, right? So now I have 1/2 times x plus 78 over 1. And if I do some multiplication there with fractions, multiply top, multiply denominators, don't I get this, which is what Cameron told me?
Yeah.
Okay, so the hope is that we recognize that those two things are the same thing. Now, I like what Cameron was saying, is because he says if you write it that way, let me get rid of that, you can realize that I got to multiply both sides by the LCD. That 2 and that 2 cancel out. Come over here, multiply by 2, and I get 14x is equal to x plus 78. Subtract x from both sides. Okay. Now, how many times does 13 go into 78? Does it go in evenly?
No.
78 over 13.
Wait, yes.
6 times. Okay, so x ends up being 6. Okay. So if x is 6, what's 7 times 6?
42.
42. Okay. What is this going to be if x is 6? 10. What's 10 plus 74? 84. What's half of 84? 42. Okay, so that's the check, right? Now, if you're a person that wrote things this way, 7x is equal to 1/2 x plus 78. Hopefully now you see why we're going to multiply both sides by 2 to get rid of the 1/2, right? Okay. But what I want to try to show you here is that there are many different approaches as you write your algebra down. Now, they're really doing the same thing, but the steps and what you write down might look a little bit different. Could I do this? Could I multiply that 1/2 through and get 7x is equal to 1/2 x plus half of 78 would be what? What's half 78, guys? 39. Okay. Now, can I multiply everything by 2 to get rid of that 1/2?
Yeah.
You want to multiply every single term by 2, I get 14x, 1x, and 78, right? I get that x plus 78 that was right here, okay, as the numerator in the equation that we did prior, right? Okay, so that's still going to give me x to be 6 in this case. There's another approach. Let me go this way. The other approach is exactly what we did when we had that denominator of 2. We multiplied both sides by 2, right? And this is where people kind of get themselves into trouble when they do this. I'm going to multiply this side by 2. Then we'll multiply this side by 2. Well, it's not hard to multiply the left-hand side by 2. It gives me 14x, right? Okay. By knowing that we've already done this approach one or two other ways, we should know that we're left with x plus 78, right? So we should know that really what we're doing is multiplying those two things together and getting our x plus 78. But I want to explain that and explain why we're doing it this way. X plus 78, like we said earlier, when x is some number, adding 78 to it, you get some number, right? Okay. So I'm just going to write this here. I'm going to say that thing there is just some number. Would you agree that 1/2 is just some number? And would you agree that that 2 right there, that I multiplied the right-hand side by, is just some number? Do you guys agree with all that? And all of these numbers are getting attached together through multiplication. 2 times 1/2 times this quantity of x plus 78. So there should be multiplication occurring in between all these things, right? Well, you never, ever, ever, even though you may think this, you cannot multiply 3 numbers together at the exact same time. Even your calculator won't do it. Okay? What happens when you want to multiply numbers like 2 times 3 times 5? You don't multiply those together all at the same time. You do this, don't you? Multiply those together, and now get 6 times 5, and now multiply those together, right? And get 30. Or, if I had 2 times 3 times 5, couldn't you multiply those two together? Get 15, and then multiply that by the 2. So when I have these 3 numbers up here, no matter what they are, I'm really going to multiply maybe these 2 together, and then multiply by the third one, or maybe multiply these 2 together, and then multiply it by the third one, or my last grouping could be multiply that one and that one together, get that product, multiply that product by that middle one, right? Hopefully you guys realize that it makes most sense to multiply those 2 together, right? What do I get when I multiply those 2 together? You get 1. They're reciprocals, right? So now those 2 multiplied together give me that 1. I still have the x plus 78 as that third number that I need to multiply together, right? Well, that just leaves me with x plus 78 then when I distribute that 1 through. And I come over to the left-hand side and multiply that left-hand side by 2 as well. Okay? The number one thing, and the reason I talk about this, hopefully you guys are seeing, well, that's why is he talking about this? It's a waste of my time. Hopefully that's your viewpoint. But if you're a person that's missing these, think about what you're doing. I get a lot of people to take this 2 and multiply it by that 1/2. And they understand to do that. That's perfectly fine with them. They get 1. But then the next thing they do is they take that 2 and they multiply it by that x. And they take that 2 and they multiply it by that 78. You cannot do that. Is that all right with everyone? And this is going to become something that we're going to use a lot of. We're going to deal with some formulas here in the next couple weeks of different shapes, triangles for the most part, though. And we're going to come across this algebra. And the number one error that I see with algebra like this is that people want to multiply that 2 by everything over here. You can't. Okay? For the same reason of if I had 2 times 3 times 5, nobody takes the 2, multiplies it by the 3, gets 6. Takes the 2, multiply it by the 5, and gets 10, and then multiplies those together, gets 60, do they? No. Or nobody takes the 3 times the 2 and gets 6, and then the 3 times the 15, 3 times the 5 and gets 15, and then multiply those two things together and gets 90. Okay? Because we should get the same number back every time we multiply, right? Well, one route I got 60, the other route I got 90. Those are not the same. Okay? So that algebra doesn't make sense to us. Okay? I want to make sure that we understand why we can't do that. The other question was 14, and there's another algebraic thing here that we see. Again, it's the same picture, it's the same idea, is that 3x plus 5, your mid-segment, is going to be 1/2 of the sum of your bases, right? Well, your bases here are 7x plus 7. Okay? And the last one, we use an approach that maybe we distribute the 1/2. Maybe that would work. It makes sense, maybe. Does it really make sense a lot of times to distribute that 1/2? I've got numbers like 7 inside those parentheses. Because you're going to get something ugly, right? Usually you only want to multiply or distribute, because you've got options in an equation. Do I distribute or do I maybe double both sides? You really only want to distribute if the things in the parentheses are a multiple of your denominator. Okay? So 7 is not a multiple of 2, right? Okay? Multiples of 2 are your even numbers, correct? So you would only maybe distribute, kind of foreshadowing, and it's only logical or makes sense, because it only makes the equation easier if the 7s in there were even numbers. Okay? Then you might distribute, and it makes things pretty simple. If that's not a viable option, if it doesn't make sense to do that because it's going to create harder algebra, we'll multiply everything by 2. Okay? I'm going to multiply both sides by 2. I should probably phrase it that way. Because now you got a number times a number times a number. It makes most sense to multiply those two numbers together because they give me 1. And then all I'm left with is 1 times this number here. So I write that as 7x plus 7. Now I got to come over and multiply this side by 2. Okay, and it makes sense to use the phrasing multiply a side by 2 or double a side. Because now I got to remember that I need to distribute that 2 to both parts, 3x and 5, and I get that 6x plus 10. Okay, because think about this. If I've got 3x plus 5, when x is 0, let's say x is 1. If x is 1, this ends up being 8, right? Okay. Well, if you double 8, what should you get? You should get 16. Okay. So if I do this, when x is 1, I should get 16, right? But if I accidentally just say, okay, I'm just going to multiply the left-hand side by 2, and I just get 6x plus 5, okay? When x is 1, what happens here? What do I get when x is 1 here? I get 11, right? Double 11. 22. Not what we need here, right? We needed 18, okay? So you need to make sure that you distribute that 3, or that 2 to the 3x plus 5 to get the entire amount that we're trying to develop here, okay? Subtract 6x from both sides. Subtract 7 from both sides, you get x to be 3, right? The built-in check then is to say, okay, if 3 is my x value, then this thing here becomes 14. And this becomes, what, 26? What's 26 plus 2? 28. What's half of that? 14, right? Okay. Some people in the last class made the argument that we know that just using arbitrary values, let's say EF, which is our mid-segment, we said that that is 1/2 AD plus BC, right? Could I do a little bit of algebra here and say 2 mid-segments should equate to 1 sum of my bases? Can I do that? Okay, so some people like that. Some people prefer that red formula and say, now every time I see one of these things, I'm going to say, whatever my mid-segment is, I'm going to double it. So here I see my mid-segment is 3x plus 5, I'm going to double it. Gives me 6x plus 10. I'll set that equal to the sum of my bases. Well, sum of my bases then is 7x plus 7. And I get that equation that is in blue up there with the 6x plus 10 equals 7x plus 7. So if you want to do that, feel free to do that. There's nothing wrong with that. What that's saying, if I were to take AD and BC and put them end to end, okay, using segment addition, okay, that will equate to putting EF end to end 2 times. And give me the exact same size of the segment. Is that something we can do? All right. Let's talk about kites.